So the second step after you guys have set up a matrix equation is actually using the inverse matrix to solve. But we're going to first talk about determining if a matrix is the inverse of your coefficient matrix. So to actually calculate the inverse matrix, it would be super tricky. It's a little time consuming, and a lot of times it's decimals. Usually we would use a calculator. So we're just going to kind of talk about what an inverse matrix is and how you determine if it's one or not. So the inverse of something, when you multiply two things together, the original and the inverse of the original, it's really what happens is when you multiply them, you're going to get a value of 1. So like 2 times 1/2 gives you the value of 1. If you guys typed 2 to the negative first in your calculator, you would get 1/2. So the inverse, when you multiply with the original, equals the value 1, but it's also noted with a -1 power. So 2 to the negative first is 1/2. 2 times 1/2 equals 1. -3 times -1/3 equals the value 1. 5/11 times 11/5 equals the value 1. If you guys typed 5/11 to the negative first, you would get 11/5. So the inverse is noted with this little -1 power, but when you multiply with the original, it equals the value 1. So with using the inverse matrix and trying to solve for x, y, and z, we'll be able to solve for our variables here. So let's just sort of talk about, I feel like this is not super important. We're going to skip this part. So are these two matrices inverses? So we're trying to figure out if the coefficient matrix from above, that 1, 3, 3, 1, 4, 3, 1, 3, 4, if this matrix is the inverse. If it is, we get this identity matrix with a 1, 1, 1 diagonally. What that really represents is 1x, 1y, and 1z. So if this is your inverse matrix of the original, it will equal this identity matrix. So what we have to check, or what we need to do, is multiply these two matrices together. So we've got a 3 by 3 and another 3 by 3. They have to be the same if it's an inverse, but that just means your new matrix will be a 3 by 3. So remembering it's your rows times your columns. So 7 times 1 is 7. -3 times 1 is -3. 4 times 1 is 4. We'll just do all three here. 7 times 3 is 21. -3 times 4 is -12. 4 times 4 is 16. 7 times 3, 21. -3 times 3, -9. 4 times 4, 16. So let's just do this first row here. So remember, we're trying to figure out if it equals this identity matrix. It's only an inverse if, when we multiply these two guys together, it equals that identity matrix. So let's see, 7 minus 3 is 4, 4 plus 4 is 8. We could really stop there. 21 minus 12 is 9. And this should not be 16. This should be 12. So 21 minus 12 plus 12 will be 21. And 21 minus 9 is 12 plus 16 is 28. So what you guys are looking for is if it's equaling 1, 0, and 0. So without even having to finish doing this, because we have 8, 21, and 28, I know that this matrix is not the inverse. So you guys don't have to finish doing the multiplication, because as soon as you don't get that first spot to be 1, it doesn't, we literally could care less what the other ones are, because it's not going to work. You have to have 1, 0, 0, 0, 1, 0, 0, 0, 1. It has to be those values exactly, because we want only one x, no y, z. Only one y, no x or z, and then only one z. Like, it has to be this exact matrix for this to be an inverse. So we don't even have to multiply the whole thing or finish the process. When we are doing this, if we don't get that very first spot to be 1. It's just not going to work. We won't be able to use it. So, still using our coefficient matrix, in this second problem, or this second example, let's check these two to see if they equal that identity matrix. So, across and down. Give myself enough room to write here. So 7 times 1 is 7, negative 3. Negative 3 times 1. And then the next column, 7 times 3 is 21. Negative 3 times 4 is negative 12. Negative 3 times 3 is negative 9. And then your last column, 21. Minus 9, minus 12. So let's see what we get for this first row. So 7, negative 3, 6. So 7 minus 6 is 1. Negative 12 and negative 9 is negative 21, plus 21 is 0. Negative 9 and negative 12 again is negative 21, plus 21 will be 0. So, that one, so far so good. So let's check your next row and your 3 columns. So negative 1 times 1, negative 1. 1 times 1 is 1. 0 times 1 is 1. Negative 1 times 3, negative 3. 1 times 4 is 4. 0 times 3 is 0. Negative 1 times 3, 1 times 3, 0 times 4. So what do we got here? Negative 1 plus 1 is 0, plus 1 is 2, which should not be, so let me check my math. Negative 1 times 1 is 1. Oh, this guy should be 0 right here. There we go. And then negative 3 plus 4 is 1. Negative 3 plus 3 is 0. So, if it starts out as like in the pattern of being the identity matrix, guys, it's probably going to be the identity matrix. You really are just kind of getting it started to check. So I am confident that this will be, I also have the answer key, but hey, this will be your identity matrix. So you don't always have to finish or do all of the multiplication. You're just checking to see if it is the identity matrix, or if it will not be, to see if they are inverses. So it is the inverse, that little negative 1, it is the inverse matrix if when you multiply it with the coefficient matrix, it gives you this identity matrix of 1, 0, 0, 0, 1, 0, 0, 0, 1. That is the goal at hand. If it doesn't do that, we can't use it to solve our systems of equations.